Number 10 gives me this equation, this cubic equation. And notice how I graphed it on my phone. And what it asks is, where are the tangent lines horizontal to this x cubed? And notice I have a maximum, a relative max here, and a relative min here. And that's the only spot where I can draw a line that's going to have a slope of 0. Notice the slope would be 0 because it's a horizontal line. So if I use that notation hoi again, if I use that notation hoi, it would be a horizontal line whose slope is 0. And slope is the derivative, or dy dx, however you want to say it. So this is a very conceptual question. It wants to know at what coordinate there's a relative max, and at what coordinate there's a relative min, without using the graphing utilities such as Desmos, which would give it to me instantly. Really nice. Notice, it's going to be a 2.33 and 51.815 and 7.1. So really nice technology, but that's not what we're looking for here. Let's remember that. The answer is 7 for the x value, 1 for the y value, and 2.33 for the x value, and 51.815 for the y value. Notice 2.33 is smaller than 7, so it comes first. Now, because 2.33 is smaller, that's going to generate my max on the curve of x cubed, because the general shape of x cubed starts down on the left and then does a little bump and another bump and then ends up on the right. So the smaller number is going to be related to the max, the higher number. The bigger number, 7, is going to be related to the min, the 1, the lower number. So it's going to be the small x value, the big y value, the big x value, the small y value. So the first thing I want to do is take the derivative of this. And that derivative is pretty straightforward. It's going to be y prime, the derivative, equals 3x squared, notice 3 times 1, minus 28x plus 49. Now, I have to set this equal to 0. I want to know where the derivative is equal to 0. Now, this calculator can solve a quadratic if it's set equal to 0. So I'm going to turn on my calculator, and now I'm going to hit the mode button. Mode, then 5 for equation, and 3, so now it says x squared, 3, mode 5, 3, and now it's going to ask me to do the quadratic formula. So I type in the 3, I type in the negative 28, and I type in the 49. And these are going to be the x values of where I have a max and a min. So 7 is one of the values. I need to figure out what the y value is. 7/3, or 2.33. 7/3 is the other x value. And let's recall, from the graph, we had those values. Now to find the y value, I have to plug it back into the original. To find the y value, I have to plug it back into the original. So I have my 7, I have my 7/3. Now to find out that y value, I have to plug it not back into the derivative, I have to plug it back in to the x cubed. So I'm going to hit mode 1 for normal computational mode, and now I'm going to plug in 7 to that cubic function. So I'm going to so now I have to plug that 7 in to the x value of the original, not to the derivative, to the original. So it's going to be parentheses 7, close parentheses, to the third. Now you want a right arrow to get it down. Minus 14, parentheses 7, put in those parentheses because I'm plugging 7 into every x value, squared, plus 49, parentheses 7, close parentheses, plus 1, and that should give me that y value of 1. Now I need the other y value. Now I have to go back and plug in 7/3. I have to plug in 7/3. This calculator is pretty convenient to plug in 7/3 now wherever there's an x. Instead of clearing it out, I'm just going to back arrow into the problem. And right there, see on there, I'm going to hit this fraction button and put the 3 there. I'm going to back arrow. And all I did is I got it right behind the 7. And then I hit this fraction button here. And then I put the 3 on the bottom. Back arrow, pretty convenient. Hit that button, and I put the 3 on the bottom. Really crazy decimal, 1399 over 27. And that's what they want for the answer, 1399 over 27. Let's see what the decimal value is for that. I bet you it's 51-ish, and there it is. Just like the telephone gave me. Part A wants to find the derivative of this. So notice they give me different letters. I'm just going to do p prime of t. I think it's easier for me to write. The derivative of this big number is 0. The derivative of 3000 t squared is going to be 2 times 3000. That would give me 6000 t, because don't forget I have to subtract 1. So that's my answer to part A. Now part B, they want me to find the population after 20 years. That means I take this 20 and plug it back into the original, not into the derivative. The growth rate, whenever they use the word rate at t equals 20, if they say rate, the rate is a slope. That's when you plug it into the derivative. There's some keywords that we have to look out for. So I'm going to take this 20 and plug it back into the original. Let me use a calculator for it. Clear out my last problem, and it's going to be 600,000 plus 3,000 parentheses, and I'm throwing in the 20, close parentheses squared, hit equals, and I get my population after 20 years. And you have to be careful counting the zeros, 1, 2, 3, 4, 5 zeros. 180. So 1,800,000 after 20 years. Now there's two ways to do the last part. I could either take the 20 and plug it into my derivative, that would be p prime of 20, or I can use the calculator and throw 20 into the original using the ddx button. I'm going to take the 20 and throw it into t. So it's going to be 6,000 times 20. So I get a 12 with 4 zeros. Sorry, 120,000. I'm going to use the calculator to do that to check to see if it would have worked. So I'm going to take the original equation, 600,000, but I'm going to hit shift, derivative, and I'm going to type in the original equation of 600,000 plus 3,000 t squared, 6 plus 3,000. Now I don't have a t button, so I'm going to use alpha red x for any variable. Then I have to square it, and now I'm going to evaluate that at 20. And it should also give me the 120,000. It should give me the same result. Notice I'm plugging it into the derivative. I'm plugging it into the original, and the calculator is going to take the derivative. And there's the answer. So I'm going to implement the product rule. They want me to multiply x minus 7 times 5x plus 3. What they actually want me to do is find the derivative using the product rule. So I'm going to, first thing, notice that I'm multiplying two items. So that means I use the product rule. I'm going to crack it down the middle like an egg, and I'm going to label the first item as u, and the second item as v. I'm going to use this rule, u dv plus v du. That is the product rule. So u equals x minus 7. V equals 5x plus 3. The derivative of u, du, equals, well, the derivative of x minus 7 is 1. dv, the derivative of 5x plus 3, is 5. And here comes the product rule. I take this u and I multiply it by dv. That's where I get u dv from. I have to wrap it, so x minus 7 times 5 plus, that's up in the rule, v du. So that's going to give me 5x plus 3 times 1. And that's the product rule. The second part of the problem wants me to expand or multiply x minus 7 times 5x plus 3. You could use the FOIL method. I use a Punnett square, and here's all I do. I set up a 4-square Punnett. I do x minus 7 times 5x plus 3. That would give me 5x squared minus 35x plus 3x minus 21. So the expanded version of this would be 5x squared minus 33x minus 21. That's the expanded version, and that would be part B. The third part would say, find the derivative of that. So once I have that, I can find the derivative, and it's actually pretty easy. It would just be 10x minus 33. Now I could have arrived at 10x minus 33 with this, but only if I simplified it. So notice that would be 5x minus 35 plus 5x plus 3. And when I combine like terms, 5x plus 5x would be 10x. 3 minus 35 would be minus 33. So the derivative simplified is the same as derivative after I FOIL it. So now I'm asked to find the derivative of a fraction. This fraction could be simplified, but they want us to go through the steps. We're going to use this thing. If I have a fraction of a high value and a low value, you're going to do low d high, low times the derivative of the high value, minus high d low, the high value times the derivative of the low value. Draw a line and then square whatever the low is. So some people try to use that square the low to go right to the answer as rapidly as possible. So what is the immediate result applying the quotient rule? Notice I have the w squared, so they try to choose c, but I'd rather you actually go through the steps. So I have a high value of 5w cubed minus w, so I have a high value and I have a low value. So my high value is 5w cubed minus w. My low value is just w. Now I'm going to do my d high. My derivative of the high is going to be 15x squared minus 1. The derivative of my low, the derivative of w, is just going to be 1. Now we have to be careful. Notice how I put 5w cubed and the derivative is 15x squared. It will mark you wrong if you put the wrong variable in there. You have to try to keep track of the w's and the x's. So now I'm going to implement the quotient rule. Low d high, less high d low. Draw a line and square the low. Low, d high. So I'm going to use the quotient rule. The low value, low times the high value, derivative of the high value. So low d high, that's going to give me w times 15x squared minus 1 minus high d low. That's going to give me 5x cubed minus w times 1. I draw a line and I square the low over w squared. Now that matches up with choice C. Now they want me to simplify this answer. So that means I have to do a little bit of algebra and distribute the values and simplify the variables. Once again, I messed up with the variables. I put an x when it should have been a w. I put an x when it should have been a w. So I'm going to distribute the w, and that's going to give me 15w cubed minus w. Now I have to distribute the negative, actually a negative 1, but I don't need to even pay attention to the 1. So it's going to give me minus 5w cubed plus w. Draw the line over w squared. Continue simplifying. 15w cubed minus 5w cubed is 10w cubed. Negative w plus w is 0. Divided by w squared. Notice, I have w to the third over w squared, so that's going to simplify to 10w to the first, or just 10w. Now, they wanted me to simplify the original and then figure out what the derivative is. Well, it has to be 10w. It has to be 10w. Let's simplify the original. So basically I have to divide both terms by w. So I can split this up as 5w cubed over w minus w over w. And that's going to give me 5w squared minus 1. And now I'm going to take the derivative of that. I'm going to take the derivative of 5w squared minus 1. And notice, if I do the power rule, that's going to give me 10w. Are they the same? Yes, they have to be. I have a difference quotient and just a polynomial. So really quickly, I can take the derivative of this, and the back end of my answer is going to be 3x squared. So I have to save that for later. Notice I have the high value is 4x minus 9. The low value is 6x plus 1. I have to take the derivative of the high. The d high is going to equal just 4. The d low is going to just equal 6. I'm going to implement the quotient rule. Low d high, less high d low. So I'm going to wrap this up and multiply it times 4. So it's going to give me 6x plus 1 times 4, less or minus high d low. That's 4x minus 9 times 6. Then I draw the line, and I have to square the low. And then I draw my line, and I square the low. Don't forget to wrap it. And I'm not done. That's the derivative. But remember, I have to bring down this plus 3x squared. And that's the derivative. You can just type that in if you want, and it should work. This is going to be an example of the product rule because I'm multiplying a quantity times a quantity. I could FOIL this out if I wanted to, but I'm going to use the product rule. Notice I rewrote the 4 over x as 4x to the negative 1. That has a power of 1, and when I bring it up to the numerator, it changes that 1 to a negative 1. So I'm going to crack this down the middle like an egg, and I'm going to label the left value as u, and the right value is v. So I'm going to have a u equals 5x squared plus 7. I'm going to have a v equals this long equation, 8x minus 9 plus 4x to the negative 1. Now my du, or my derivative of u, that equals 10x. And the derivative of 7, let's recall, is 0. My dv, the derivative of 8x minus 9 plus 4x to the negative 1. The derivative of 8x is just 8. The derivative of negative 9, the derivative of any number is 0. And then the derivative of 4x to the negative 1 using the power rule would equal negative 4x to the negative 2. And the rule is u dv plus the v du. So I'm going to take the u and multiply it times the dv. This value times this value. Or some people just say crisscross applesauce. I don't know why. So 5x squared plus 7 times 8 minus 4x to the negative 2 plus v du. I don't know if I can fit this. 8x minus 9 plus 4x to the negative 1 times 10x. We don't have to simplify it or anything like that. Just leave it like that. So it says find the equation of the tangent line. So notice I have a y equals and a y equals. I'm going to be thinking that I'm going to need to use y minus y sub 1 equals m, the slope, or the derivative, at x minus x sub 1 in this problem. So I have to take the derivative at the origin. So my point is going to be 0, 0 at the origin. So I'm going to take the derivative of this, evaluated at x equals 0, to find my slope, or my derivative. I'm going to hit the shift and the calculus button. There's the derivative. Hit the fraction bar. And now I'm going to type in the equation, negative 2, alpha red x, down arrow, parentheses. I don't know if I need them, but I'm going to put them. Alpha red x squared plus 1, close parentheses, at x equals 0. And let's see what that slope is. That slope is negative 2. So if we take a look, I have a point, 0, 0, and a slope of negative 2. I use my point slope form, so I write down y minus y sub 1 equals the derivative times x minus x sub 1. The derivative or the slope is negative 2. So I plug in that 0, I plug in that negative 2, and I plug in that 0. When I simplify, I get y equals negative 2x. Second part of the problem now, they want me to do the same process, but at 1, negative 1. So I have a coordinate 1, negative 1, and I need to find the slope. In order to find the slope at 1, negative 1, I'm going to plug in the derivative formula. Notice I already have it there. I already have the equation, so all I have to do is back arrow and change that 0, x equals 0, to x equals 1. And that will give me the slope at x equals 1. And the slope is 0. So now I have to write the equation. This is x sub 1, this is y sub 1. Y minus y sub 1 equals m times x minus x sub 1. So y minus minus 1 is y plus 1 equals 0 times x minus 1. Notice, when I do 0 times this, I get y plus 1 equals 0. So the equation is going to be y equals negative 1. Another way of looking at it is when the slope is 0, that is going to be a hoi. And the equation when the slope is 0 is the y value, or y equals negative 1.